Okay, so let's get started. Okay. Um, See, this is actually the last two unit that we are going to cover before going to the final, and because we pull forward the final to December the 21st, right? Okay. So actually, after next week's class, you only have a very short time to prepare your final. That would be a challenge. Okay, so today I'll try to go faster and try to maybe cover more, uh, so that you have more time to prepare your final presentation. Okay, and the format of final presentation is exactly the same as the midterm. That every team you will need to prepare or like 8 minutes present 8 minutes video, okay, and we will uh, we will have a cross rating, okay, and then uh, actually we'll have prize and awards for the winners of the contest, okay. Good. um, so let's have a quick uh, has a quick review of our last week. What have we done last week? We do a predictive, kind of like a predictive medication uh, example, right? Okay, and in that example, we use data to make a model that predict the probability of poor care, right, for diabetes patients, isn't it, right? And I told you that again and again that the actual business analytic actually just gets started after you have the model, okay? You do the model, you do the prediction. If you do not take action, right, you basically, that model would do no good to you at all, right? So we need to turn the prediction into a decision, right? That's the basic idea that we go through last week, okay? Isn't it, right? So what kind of decision that we are making uh, is it's our decision is actually um, based on the result of data and prediction, right? When we make the model, we make the prediction. Actually, for every uh, diabetic patients, we can predict its probability of being poor care, isn't it? Right? Okay. So in our data, we actually have some poor care patient, uh, uh, and there are patients who are actually good care, right? So what is this? In this histogram is actually the result of the prediction, right? You build model and you after do the prediction, you actually have this distribution of predicted probability, right? See, as I mentioned several times before, the when we when our target variable is a binary variable, for example, like poor care or good care. In our data, in our observation, we only know that this that target variable poor care only have two values, right? 0 and 1, true or false, yes or no, right? That kind of prediction. Now, the model actually do not predict 0 or 1, right? What does the model predict? This y variable has only two values, right? But when we call the predict function, what is this predict function return to us? Is it 0 or 1? It's not, right? It actually returns the probability y equal to 1, isn't it? So for every patient, we actually know their probability, know his or her probability of being poor care, right? So the probability is actually a value between 0 and 1, right? Isn't it? See? So the prediction, if we gather all of the prediction for all of the patients in our training and testing data, we will actually have a kind of like a classified histogram, right? The red color is actually that data actually have a data. We have two types of people in our data set, right? One type of people actually have the y equal to 1, and the other type of people actually have 0, isn't it, right? So the prediction actually give us the probability for each individual, right? Okay, but we need a cut-off probability. We need a cut-off threshold, right, to determine whether we want to take action on this poor care patient, isn't it, right? And that is the decision we want to make, right? How do we make this decision? Still remember that? Only the prediction is not enough, right? Because we do not know which cut-off probability we should use, right? To take action on it, right? And in order to that, in addition to this probability, we need to have the payoff matrix, right? See, right? The risk of the cost of risk, right? And this is the cost of prevention, isn't it? Right? Okay. So you have this payoff matrix, and basically it comes from our assumption, isn't it? Right? And then we simulate this cutoff probability. We move that cutoff threshold from 0 to 1, right? And when this threshold moves, this confusion measure will change, isn't it? Right? So at the end, we will have kind of like a So at the end, we will have something like this, right? When we change the cutoff ratio from 0 to 1, okay? First of all, the confusion measure change with the threshold, isn't it, right? And we do a product of confusion metric and sum of product, I should say, for these two metric, and then we have expected payoff, right? Okay, so when we move the threshold from 0 to 1, we will see our expected payoff for each of the threshold cutoff probability, isn't it, right? And then we simply, this is, we call simulation, isn't it, right? So we can simulate the probability, and then we know, we can tell that what is the optimal threshold, okay? That would lead to the maximum expected payoff, right? Isn't it? That is basically what we do last week, isn't it? Okay? If you still remember that we have one of this simulation program. Okay. And this is the simulation result, right? Okay. And in order to get this simulation, we actually can make some assumption about our cost of prevention, and also our the effect of our prevention action, isn't it, right? So basically, if you change this assumption, the result of the simulation will change with it, right? So we know that in what scenario, in what situation, how our optimal solution would change with the actual business situation, isn't it, right? That is the basic idea that we learned last week, right? And actually, this is the basic idea that we are going to do in our final presentation, okay? That we were changed to the TAFAN marketing training type of task instead of the preventive medication, okay? Still, we are doing this logic, okay? We are still doing this. This chart, we have used it for like 20 times already, okay? So as I told you that in the second half of the semester, we are doing basically this this part of the action, okay? So first of all, we make prediction, right? We have data, we make model, and then we do prediction. And in the case of marketing, basically we want to predict two things, right? We predict for each of the customer, right? We want to predict whether he would buy or not, right? And that result will be a probability of purchasing, right? For each individual, the first thing we want to predict is whether he will buy in next month, right? And that result will be a probability, isn't it, right? So for every individual customer, we know we can predict its probability of buying in next month. And the second thing we predict is if the customer buy, how much money, how much revenue we will get from this customer, right? So we want to know the predicted revenue. Again, this is for every individual customer, right? So for every individual customer, we know their probability of buying, we know their expected revenue contribution. And from these two values, we can calculate the value of this customer to the company. I'll do that later, right? Later in this course, I'll explain what is a lifetime value. Basically, in modern marketing, marketer can use data to calculate the value of a customer to the company to estimate that expected value, right? Okay, so I'll tell you how to do that later on. Okay, so today I'm going to in the TAFAN's context, I'll tell you how to do the model, how to do the prediction. Okay, and how to calculate the lifetime value. And if we have time, I'll also cover some of the assumption and simulation type of things, right? Again, only the prediction, as I told you, right? If you only have this prediction, it's not enough to find the optimum solution, okay? You always need to do some assumption, right? As we do here, right? And the assumption need to be a general and flexible type of assumption, right? Okay, it must be reasonable. It must be general, and by general and flexible, I mean the prediction actually must be like adjustable, right? So you can adjust your assumption and simulate your business model, right? Simulate the logic of your value creating logic, right? So with that assumption and together with the prediction, then we can kind of like evaluate the now this is data model prediction, right? and you will have some different instrument, right? Like we have done in last week's course, when we have like 5 different drugs, right? Okay, so every drug will have a different type of pair metric, isn't it? Right? Okay, so the optimal solution for each of the drugs are different. Right? So the combining the prediction and also the assumption, right? We actually can make simulation and determine how to choose. First of all, how to choose how to design and choose the instrument, right? And secondly, what determine who to apply this instrument, right? Okay. And the third thing is we want to evaluate the cost effectiveness when we apply such instrument to such group of customer, right? That is basically the business analytic process. So it's not just building model and doing prediction, right? It's actually this assumption and simulation part is actually more important than data prediction. Let's say we still need to do a data prediction, right, before we can do the simulation here. Right? So today I'm going to let's go back to the material today. See, that's why I say it again and again that you need to be punctual. Otherwise, if you miss this part, it will be very difficult for you to connect what we are going to cover this week to to last week. Right? It's kind of like very easy to get lost. Okay. So now today we are going to unit 11. Unit 12. It's called predictive modeling. Okay. Okay. And I'm going Tafang as the example of to do the predictive modeling. And basically, as I told you that doing model is actually quite easy. Doing prediction is actually quite easy, right? Basically, we just make a function call, and then you have the model already, right? And after you have the model, you make another function call, predict, then you get the prediction. Right? So it's like previously when we do the model and do the prediction, it's kind of like very easy, right? But actually, when you deal with the real business data, it's not so easy. Okay, as you will see, that it's kind of like a pretty lengthy process. You'll go through a very lengthy process before you actually can process the data and make making data, doing prediction. Again, it's still one function code, but to prepare the data for training, for testing, to prepare the data for like probability and for the amount of buying, right? It's kind of tedious. Okay. So you go through this kind of lengthy process in how to process the real data, real business data to do the predictive modeling, right? Now, predictive modeling, as its name suggests, we are predicting the future, right? So basically, we are using the history data to predict the future. Okay, so so basically, if you still remember, in the Tafang database, what we actually have is a data of 4 months, right? If you still remember that, what we have is the data for 4 months, from like November to February. Okay, okay, so 4 months of data, and in the midterm, when we do the exploration, we kind of aggregate the data, right? The data itself is actually, the raw data is, every record is actually an item, right? And we aggregate the item into transaction, into order, right? And then every customer would have several purchase, right? And every purchase will have several items. And the data itself, the raw data itself, is in this label, in the item label. So we need to aggregate item into transaction and aggregate transaction into customer, right? So that we know that for each customer, how many times this customer purchased, right? What type of product he purchased, right? And what is his revenue and profit contribution to us, to our company, right? That's what we have done in our midterm, okay? And at that time, when we do the aggregation, we kind of like aggregate 4 months of data together to know the customer's entire behavior, right? But when we are doing predictive modeling, we cannot do that, right? The reason that we cannot do that is that if we want to do a prediction, right, we actually want to predict, let's do it first. I think it would be easier for you. First of all, we need to prepare the data, okay? Now, we have 4 months of data, and our purpose is to predict the next month, right? We want to predict the behavior of customer in March. But in our data, we don't have March, right? We only have the data to the end of February. March is in the future, right? So nobody knows whether a customer will buy or not buy. And when he buy, we don't know how much money he will buy in March, right? Okay? So when we do predictive modeling, we need to push forward and do the aggregation again, right? Okay? We kind of like need to reserve the last months of data, the next period of data, to build our outcome variables, okay? And we use the data, the first 3 months of data, to do our predictors, okay? So we need to split the data. First of all, we push forward the time of data period, push forward 1 month, 1 period, okay? So we kind of aggregate, for these 3 months, we kind of aggregate the number of time he is buying, the average buying value, that type of things, right? Where this customer live, what is his age, the revenue, total revenue, and total profit contribution. Okay. Now this aggregation is not aggregate the entire 4 months. We can only aggregate the data for the first 3 months to do the predictor. Right? The reason is that we need to reserve 1 period. We need to reserve the last period of data. Okay. To get to make our predictor, right? Okay. So if I aggregate the first 3 months of data to make the X, to make the predictor, okay, and then for the last months of data, because it is very easy, right? If I have the data in February, now for each of the customer, I can tell whether he will buy or not, right? For those people who buy in February, I will set this buy to 1, otherwise it is 0, right? So we have the outcome variable for us to predict the purchase probability, isn't it? Right? Okay. And then if a customer buy, then we know how much amount he buy, right? Okay. And that will become the target variable for our expected revenue model, right? We need to build two models, right? So we need two outcome variable, okay? So the first outcome variable is whether a customer buy, right? And that is a binary variable, 0 and 1, okay? We build a model for buying probability. And second thing is the buying amount, right? That would be your numeric model, okay? So so before we can do the model, we need to prepare the data in this way, right? We need to aggregate the data again, and this time we cannot aggregate the entire 4 months of data. We only aggregate the first 3 months of data to get the historical behavior of this customer, and we reserve the last months of data to make our outcome variables. Got it? Any question up to this point of time? It's good, right? Okay. And then after doing this split, we also need to split the training and testing data, right? Okay. So we combine this X and Y, we will have a data frame, right? And in this data frame, each raker is a customer. So we have a data frame of like about 30,000 customers here, right? And every customer, we actually know their behavior in the first 3 months. And then we use this variable to predict whether this customer will buy, okay? The buying probability and the buying amount of each of these customers, right? That is the basic idea we are going to go through this week, okay? Get it? Get it? Oh, okay. So because you when you want to build model, you need to have X and Y, right? And our purpose is to predict March data, but we do not have March data, right? Okay, so we need to push backward, I should say, a month, and then to make this data frame. Again, we need to split the data into training and testing before we can make model and do prediction. Okay, you get it? Okay, okay. So let's go to the our notebook. Today in our folders, in our unit folder, we actually again we have two. We basically have two files. This is the PowerPoint file, and again I have a zip file. It's called tafan567. Okay, you get this zip file and like sorry, let me close this. You go to your code directory, right, and then download the zip file and unzip the zip file, and then you should see a folder called tafan567. Yeah? Okay? Okay, and put it in the same label as the other unit. Okay? So you will have a tafan567. Okay? This is basically the material for this week and next week. Okay? And if you follow this notebook, you basically would go through the, let me close this. You basically will go through the preparing data to do the model and then do the prediction, and also how to do a general and flexible assumption and do simulation. and then you can change the assumption and see how the result, how the optimal solution and how the optimal result varies with your different assumption, right? That's basically what we go through in this three notebook, okay? So now let's take a look at the first notebook. It's called Split. As I mentioned, basically we need to split the data and aggregate the data again before we build model, right? And prediction. We need to do this, right? Okay, so that's let's take a look at it together. Again, let's set this directory as our working directory. Okay. Remember to do that so you can follow me. Okay. And first of all, we simply load the data, right? And this is the data that we saved. Okay. Previously in Taiwan 1, 2, 3. So when we load the data, we'll see that we'll have like 3 data frame, right? You still remember what is inside the 3 data frame? The Z is the product items, right? Item within the transaction, okay? And then X is every transaction, right? And A is every what? This 32,000 is the number of what? Sorry, yeah, it's customer, right? So, but this is the aggregation for 4 months, right? As I told you before. So we need to do the aggregation again. We need to split the data and do aggregation again because right now we, because of what I already explained, right? We need to do the splitting again. So first of all, we set the demarcation date, right? It's February the 1st. And for all of the data before February the 1st, right? Which is from November to the end of January, right? All of this data would go to data frame Z. The original data is Z0, okay? So now let's go to Z. Remember that after this Z data frame only carry the data from November to January, the end of January, so the first 3 months of data. And we want to do the aggregation. The code of aggregation is exactly the same as that we have done before, so I don't do more explanation here, right? So first of all, we need to aggregate the item into transaction inlet, okay? And this aggregation will take some time because it's pretty large, right? It's 817 items, and we need to. But actually, only this time we are aggregating from Z, so we only have about 618,000 items, okay? And as you can see that you will aggregate into 88,000 transactions, okay? And that is like, that is the aggregation for the first 3 months, okay? Okay. Now, and after aggregating transaction, we want to aggregate a transaction into customer, right? Right? Remember that? So again, I'll do some outliers. I remove some outlier, right? This is we have done previously, so I'll just run through it. And then this is the aggregation for a customer. And again, we need to make a new variable. This is for calculating the recency, right? To calculate the number of days that this customer did not buy from us, right? Since his last time and the first time he buy from us. So recency and seniority, we need to use this variable date, okay? So, but this code is exactly the same as what we do in midterm, so I just run through it. So at the end, for the first 3 months, you can see that the number of record of A is less than A0, for X is less than X0, Z is less than Z0. This is because that right now we are getting not the entire 4 months of data, but the first 3 months of data, right? Okay. So up to this point of time, we already have this X, right? Okay. Now we need to make the Y variable. We have 2 Y variable, right? Buy is a binary variable indicating whether this customer buy or do not buy in February, okay? And amount is the numeric variable that measure the amount that this customer buy in February, okay? So we need to make these 2 variables and then combine these 2 data frame, right? So we have a data frame that has X and Y in the same data frame, then we can build model, isn't it? Right? So that's the idea. Okay, so and again we need to like filter the data, the February data into FEV, right? As you can see that we filter X0 and then we only choose the transaction that the date is greater than February the 1st, right? Greater than equal, okay? And then we group by customer, do the summary. Because we are only care about the amount that customer buy, right? So when we aggregate when we do this filtering and do the group by summary, we will have FEV data frame, right? And this FEV only have about 17,000 customer, okay? It's because that in February only this customer buy from us, right? And only those customers who buy from us will have a transaction, okay? So although that in the although that in the A data frame we have 28,000, okay, and only about only about 17,000 of our customer buy in the February, isn't it, right? So what we're going to do, actually if you see that the February in the beginning, it has only one, this is the customer who buy from us, right? And this is the amount that he or her buy, okay? Okay, so this is the first thing. And then the next thing we want to do, we want to merge this data frame into this A data frame, right? Okay, so when we merge it into the A data frame, we will see that the data frame will remain the same, right? The number of customers here, and there will be one more variable that merge from February, right? So and this variable would be either NA or has a number. If it is NA, it means that this customer do not buy in February, right? If it is has a value, it means that this customer buy in February, right? So after merge this amount variable into A, then it's very easy to create the buy variable, right? We just test whether this is NA. If it was NA, then it do not buy, right? And if it's NA, then if it is not NA, then it has a value, then he buy, right? So first of all, we merge this amount into A, and then from A we can derive buy variable, the second target variable, right? So as you can see that when I execute this, we have one more variable called buy, right? And it's the logic, it is a logic variable. It's either true or false, right? When it is true, you will have a buying amount. When it is false, means that this customer do not buy. So the buying amount is not a variable, right? Okay. So when doing this, we can do a quick summary, right? We do a table, right? So we know that this out of this 2A5A4 customer, this many customer buy, right? And this many customer do not buy, okay? And so the average buying probability for this entire 2A5A4 customer is about 46%, right? Okay, so this is basically we have built X and Y and put X, Y in the same data frame called A, okay? And in A we have 2A5A4 customer inside, okay? And for each of this customer, we know his behavior in the first 3 months, and we also know whether he buy and how much he buy in the last month, okay, in the 4th month. Okay, so we can do a quick summary of A, but this is just to get an idea of how what is inside A, right? Okay, so and then we need to split the training and testing data set. Okay, this is already 10 o'clock, so let's take a quick break here. Okay, we'll be back at 10 after 10. There's one thing that I would like to remind you here. Please go to the our sorry, where is that? Go to our Facebook. Go to our Facebook group, okay? And here you will see that this week we need to do the evaluation questionnaire, okay? So please take a moment to fill in the questionnaire. And for those who do not attend the class today, please tell them to also do that, okay? Okay, we'll be back at 10 after 10.